Yeah. Hello.
Yes, you are audible, sir, now.
Yeah.
Professor Ivan, you are audible now.
Yeah, Doctor Jari.
Yeah.
Yeah. Good afternoon.
Yes. Yes. Professor Nirvan,
Yes, sir.
we can start.
Okay, sir. Good afternoon to all and every participant. It gives me an immense pleasure to welcome you all to the technical session 11 of this AICTE sponsored ATAL Faculty Development Program. We are gathered here to explore into the fascinating world of piezoelectric energy harvesting, a topic that holds an immense potential in the field of sustainable energy solution. It is my honor to introduce today's distinguished speaker, Professor Dr. Scientist Ivan Parinov, a highly respected scientist, academician, and inventor from Southern Federal University, Rostov-on-Don, Russia. Professor Parinov is a chief research fellow at the Southern Federal University and a corresponding member of the Russian Engineering Academy since 2014. He has remarkable academic and research career, holding a PhD in physics and mathematics and a doctor scientist in techniques. With over 500 scientific publications, including 44 books published with renowned international publishers like Springer and World Scientifics, Professor Parinov has made significant contribution to the field of mechanics, materials, science, and piezoelectric systems. In addition to his scholarly contribution, he has been the recipient of 34 gold medal and special awards at international exhibition and has an impressive portfolio of 18 Russian and Soviet patent to his name. So I invite Professor Dr. Scientist Ivan Parinov to take the stage and enlighten us with his knowledge and insight. Sir, over to you.
Thank you, Dr. Nirvan. Thank you, Dr. Jaju, sir, from GHRCE College of Engineering. Dr. Abhay, committee member, sir. It's been really a pleasure for me to present here in such kind of FDP wherein there's a good collaboration between the various researchers and it's so may I know how I can start? Is it okay?
Yes. Yes. Now slide is visible. We can start.
Okay. So good afternoon, everybody. Yeah. So basically, I will focus the presentation in two modes: basics of 3D printing and biomedical applications. And later on, we will discuss the case studies that's the design and development of anatomical model for craniotomy surgeries. So basically, in the beginning, what basically it's 3D printing. 3D printing that everybody knows that you have been in the program since last week. So it's a various kind of process to make three differential objects that comes under the method of rapid prototyping. And 3D printing technology, so layers of metals which lay down one after one, and by which we guide the object done. 3D printings are created using CAD software. The various softwares like CATIA, the SolidWorks, then ANSYS also we can make the object. What basically it is, will not focus that much on these objects. So what there's a creation of 3D model, then into ATAL file, and it's slice laser path. So by using the various, there are so many open source softwares like a Crafty, and so by which we can slices and then the 3D printing. At last, you can see the object. So what are the projects of 3D printing objects? So you can see the four figures. One is the jewelry design, can object complex jewelry kind of designs. In another domain, you can see that automobile industry. You can see the another figure that is 3D printed shows wherein the sportsman supposed to design that. Even the can printing, you can say here the hard shaped 3D printed pizza. So it's a versatile tool for various kind of industries. As well, now coming on the 3D printing mechanical or biomedical domain. You can see four figures. On the left side, you can see that the walls. These are the walls, we can't print it. So this is a model, obviously. It's not the actual one. Yeah, another organ you can see here the ears. Many cases of like if we consider like accident, an accidents we can see we can close the object or any organ, so we can print it. Okay, another that's nothing but again this is a heart. So now it's all about that the object how it's chosen. So here we design the development of an anatomical model for craniotomy surgeries. Just look at overview of a human brain. You know that the human brain is very complex in nature. Potential of additive manufacturing to find out the solution to rapid complexity of a surgery planning, doctors, surgeons. Wherein maybe there are so many other softwares also, but I have been working in the last years. My two fellows are working or there on the mimic. So mimic another subversion is like a third printing thematic. And it's a process of designing and developing anatomical module for anatomy surgery. Anatomical surgery is like the surgery which we can say about brand, human brand. The mimic and thematic softwares are designed to develop this process. We'll see later on, just slides are based on that only. The benefits using a 3D printed anatomical model in anatomy training. Or can say the two figures wherein the what's best. Well, these two figures are the first one initially the human brain, the parietal lobe, occipital lobe, cerebellum, spinal cord, temporal lobe, frontal lobe, and the another again there are several types of parts which mentions. The difference is that in the initial one it's only six, in the second one there's so many. This is another figure wherein you can see the various small kind of objects. Will not go that much in detail as the intention is to show how the brain complex, how complex it is. So obviously it's the main part of the body wherein all the things are controlled by the brain. So a small kind of error which occurs in the surgery or like prediction of the diseases can harm too much to the patient. So the another figure which you can see that the actual brain, what if human brain content. So skull, obviously this is made for very hard tissue which we call as a skull, so bones. The second part is nerves. It's optic nerves, trigeminal nerves, ocular nerves. Then the blood vessels. So these are blood vessels. Obviously, the brain is having numerous of blood vessels. So soft tissues, obviously, it's made up of soft tissues. Then arteries. Arteries are like the connection pipelines. We can say that's the internal cerebral artery, anterior cerebral artery, middle cerebral artery. That's all. And another portion, that the last one, that's a tumor. Obviously, tumor is the unwanted portion in the brain, wherein the doctors have to remove that by using. So what's the conclusion? Every portion of the brain as above met with a different cancer types. As far as engineering concerns are there, which what the main thing is that uh, it's having a different densities. So now come to the point at MRI diagram file. So these are the very important files by which we can follow the study. So there are several diagram files which you can see. That's all the diagram files. On the right side, you can see this is not the actual patient photo, but a brain tumor. Okay. So every portion of the brain has both might be the different material densities. That's a matter of discussion for an engineer from our point of view. So that's a key indicator that doctors or the medical practitioners identify the disease. Obviously, they are having expertise with so many years to how by only distorted films they identify the exact position of the tumor. But we as engineering, we can identify using some kind of softwares. So, what's instead of add to manufacturing, that biomedical softwares are 3D printing to find out solution to reduce the cost. Obviously, we try to find out a kind of SOP we can say so that doctors or medical practitioner can understand in the virtual mode to before the surgery. So by thematic, we can segment the complete organ in various parts as per our requirement, even into 10 parts, more than 10, like 100 parts. We can divide the object. Application then the last process where we can print 3D printed prototypes for model actual surgery models. Overall, the risk of the failures of the brain surgery reduced by using virtual 3D visualization planning before actual operation. What 3D printing role? 3D printing is a rapidly developing technology can be used to create anatomical. So what the model which I have shown, so what can print that? 3D printers are computer-generated CAD file to create a physical object layer by layer. This allows for the creation of model with complex geometries on that would be different to impossible to create a traditional manufacturing methods. But anatomy surgery, let's focus on that. Anatomy surgery is a very complex kind of surgery. It's concerned with the brain tumors, obviously, it's unwanted portions. It's used to treat a variety of conditions, including brain tumor, brain occlusions, lived angiomas. Success of anatomy surgery depends upon surgeon's ability to accurately plan. So obviously, the surgeon will have to rely on his accuracy. So whenever something happens with any kind of a patient, so they must have to take the several another opinion because the predictions of a practitioner may be wrong. Means if we are talking with the 0.001 accuracy or mm, like that. Anatomical model. Anatomical model can be used to train the surgeons to control procedures. Anatomical model can provide the surgeons with a realistic view of anatomy of a skull and brain. Obviously, this helps the surgeons to plan and execute the anatomical procedures more effectively. So whenever we are going to create any kind of anatomical model, it would be a very procedures effectively. Anatomical model also can be used to teach the students wherein in the medical colleges. So if the model is mad, and then in that case, they can even do the procedures for the other students so they can understand the way of doing the operations. Now, what about some mimic? Obviously, mimic is kind of one tool we can say that by which we can using segmentations on the question of 3D printing model of anatomic structures. It has a variety of tools that can segment of data such as threshold, vision drawing, versus algorithm. The guy is also creates a 3D model. So Mimic is kind of a blend wherein made by the engineers design, and so we can convert all the diagram files into a 3D object or virtual way, and by which we can even detect the size of the tumor, which we can see at the latch on the one case study. Or you can see the interface that all these four figures are shown. Like so, this here like the number of files. Okay, on the left, if I how I can annotate it. Okay, okay, yeah. So the fourth one where you can see this a kind of a model which made by a mimic. Okay, so see design process. The process for anatomic model for anatomic surgery typically involves four steps. So first one is nothing but the acquisition of the patient data. It's a very important step. So wherein the files are in the CT scan or MRI. Segmentation is the data is the next step to segment because in segmentations, like see secretion of model, editing and refining the model, 3D printing object of the model. First step is to acquire the patient data. This data can be acquired through variety of ways, such as CT scan, X-ray. X-ray is not that much accurate, but okay, it's a traditional and the earlier used methods. MRI, MRI scans. MRI it can be a magnetic field with the radio waves to create the detailed image inside the body. Obviously, we can see MRI is used for some kind of the soft tissues, or we can use the CT scan for the heart, like bone fractures or some other kind of accidental injuries. So you can see that there are various figures. So which are the DICOM files which we can open in the mimics. Okay, so just about this curl, where the front view, top view, side view, or wherein it depends what kind of the object in the brain we want to focus. Now, what segmentation of the patient data? It's a process of dividing the complete regions into a number of events. This can be done manually by using software such as Mimic. Obviously, doctors with their practice or the practices, they can understand what would be the size of the tumor or where it exactly located. Okay? But there might be some mistakes. Softwares use the fastest than the manual segmentation, but it's not that much. So here's some segmentation. I tried to show you some kind of the actual segmentation. You can see that in the right side figures, customs, you can set the threshold. So bone, where the soft tissues, enamels with the child, bone compact bone with adult, child, adult. What's the intention to show these things? Because every compact bone, which if it concerns with the child or with the adult patients, are having a different metal densities. Obviously, suppose if you want to focus on the soft tissues, so you can use the threshold at a different levels. Creation of a model. Sure. Once a patient data has segmented, as in the earlier process, it's used to create a 3D model. This model can be done using thematic. Okay, so kind of case study which you can see here. This is a hip model. There's a spinal cord and the brain, and the last one is a brain. So you can create any kind of such model by using MRI files. Now, what basically thematic? Thematic is a kind of software where after creation of these earlier three models, if you want to segregate in the various kind of portions, wherein we can use a thematic. It's a variety of tools that can edit or reform the models such as Boolean, soft, smoothing, meshing, or there are so various operations are there. Editing or refining the model. Obviously, this refining or editing can say it is done in thematic. Later on, I'm going to show that how we can do it. So this involves adjusting size and shape of the structure, adding all in detail or changing the color of the model. Goal is to create the model to close to actual anatomy as far as possible. So again, you can see here. So the difference between the earlier and this one. I think you can see the object are shown in the different colors. So if whatever, where the fracture is, where the bone has been broken, we can focus especially on that object. It depends on here's the two colors, and the last one is the brain, wherein it's shown in the single color. So case studies. Now we will discuss about one tumor case study that involves so applying a threshold. As I told you, applying a threshold. So this is a kind of another diagram file wherein whatever where you want to focus. So this is like suppose this is a case study of a tumor inside the brain. It was again a crucial thing. So obviously that tumor is made of soft tissues. So as according to that threshold, if we adjust, we can see the tumor size. We can predict in the virtual way tumor size, as length, as even the weight of that and the exact location. Obviously, this finding virtually is very much helpful for the doctors. So these are separation parameters or the different thresholds to split mask methods. So it's a tissue and the tumor with a different threshold. Likewise, we can separate all the required masses and transporting those parts into a plate. So these three R's, like initially it was a skull, then a brain, and then a tumor. A separated brain from mass is a clear noise ready to print or surprise. So assembly of all masses on their sectional view can see as we can divide the complete virtual brain model by 3D printing source or by mimic to into a different parts, and you can see the position. You can, if I can abstract this thing, so you can see. So the middle portion, a real 3D prototype. 3D printing of model, once the model has completed, can be 3D printed. 3D printing is the process which used to find out. The 3D printed model can be used for training and simulation purpose. The virtual one. So here you can see the case study where in the scarf, the mark earlier, and the last one is the actual figure. So what FA modeling, FA frontal element modeling, and image software for cranioplasty. So it offers powerful FA analysis capabilities to apply anatomical procedures. So it's concerned with the current, not only anatomy, which we can use for any other kind of surgeries wherein the doctors can't see, plan that surgeries. Features or mimic, obviously, it's a material property assignment on that the threshold application, different match generation, the boundary condition apply. So all these are as considered with the FEA analysis we can use in the mimic software. So FA offers called this another anatomical plate, can see. So it's a model made. Suppose they can uh, design and suppose in an accidental custody, if ever lost that the complete portion. So from the right side portion, we can design the left side exact replica of the same. So my generation can see here. So benefits of different model. Coming on that, what exactly the helpful for the doctors? So they are more accurate and realistic, obviously, because the doctors used to predict the things, but for mimic or thematic, we can create the actual model which in the virtual way before surgery they can measure the size. They can customize its specific needs to surgeons and students. They are more portable, so can be used a variety of settings. They are less expensive as compared to traditional anatomical models. Also, conclusion, what exactly the study focuses on. Self-anatomical model are most valuable for training surgeons in anatomical procedures. We can say that the prosthetic surgery planning, because as the brain is a very complex and suppose you medical practitioners, whenever they open the patient or the for surgery, they might find that the size, actual size may vary or it differs, but these models are more accurate, which made by us by 3D printing are elastic than the traditional mathematical models. They can customize to the specific needs of the surgeon or the any students. All the 3D printed anatomical models are so more portable and less expensive. Earlier it was, the technology was, the machines was very costly, but nowadays, as due to the revolution, the technology, the machines are also more perfect. There are so wide kind of the varieties in the materials, even earlier is PLA, ABS, or like even nowadays there are so many other materials on which we can print some kind of the organs like the nose or ears or so biocompatible material 3D printing also is possible nowadays. Earlier it was limited with the plastics or the kind of plastics or some metal parts, but now it's for medical human organs also. This use of anatomical models has been shown to improve the confidence of the skills of the surgeons. So obviously, this is a main motto of this study and very much helpful. So I can lead more accurate or efficient procedures. So this is all from my side, wherein I try to focus on the study. So sorry, actually, due to some local conditions in our country, Ukraine and Russia, so I have not been allowed to for the that video starting. So I have to give it on the oral mode only. Sorry, Dr. Javu, for that. Thank you very much. Hello. Hello.
Thank you so much, Professor Parinov sir, for that illuminating and insightful presentation. Your expertise and pioneer contribution to the field of piezoelectric energy harvesting have left us inspired and motivated to explore more in his fascinating domain. Now, ladies and gentlemen, with this we conclude
Thank
technical
you,
session.
thank you, Dr. Nilesh. Thank you.
Welcome, sir. Now, all the participants, we conclude technical session 11, and let us take a moment to reflect on the transformative potential of sustainable energy technologies and their role into the shaping our future. Once again, let us express our heartfelt gratitude to Dr. Parinov for sharing his valuable time and knowledge with us.
Thank you.
Thank you, everyone. Stay tuned for the next session. The next session will start within 2 minutes by Venkatesh Naidu.
Thank you, yeah. You can ask questions.
Am I audible, sir?
Yes, Mr. Venkatesh, you are audible.
Adal University. We will thankful to Dr. Jaju, Dr. Abakala,
Is my screen visible, sir?
Dr. Nilesh invited me. Yeah. I think we have a great time there. So I'm having another meeting. The schedule. I had to leave now.
Thank you, Parinov, sir.
Okay, thank you.
Now, dear all participants, now we have a research scholar of GHRCE to give his hands-on training into the
Is the
Mimic
screen
software
visible,
and
sir?
Thematic software. Venkatesh, you can start your presentation, Venkatesh.
Hello, is my screen visible?
Yes, Venkatesh, your screen is also visible and your presentation is also clear.
Okay, sir.
There is one option at the below. You must hide that particular option.
All right.
Okay.
Thank you so much, Nilesh, sir. Good afternoon, everyone. It is truly an honor to be sharing here among such distinguished speakers and enthusiastic participants. Workshops like this hold immense importance as they bridge the gap between knowledge and application, particularly in the area as transformative as 3D printing in healthcare. As we dive deeper into the fascinating field, it's incredible to witness how tools like Mimics and thematic software are changing the way we approach healthcare. From designing surgical guides to developing patient specific implants, these innovations are reshaping patient outcomes and redefining possibilities. So today we are going to learn about how we use mimics and thematic software. So this presentation will discuss introduction of mimic software, also the design and development of anatomical models. So without any delay, I would like to on the software part because we need to know how the software works in real life. Okay, so this is the interface of mimic software. So as you can see, there are many options in toolbars like file, view, image, like any other software. I am assuming that you all are aware of the softwares like CATIA, Creo. So it is just like that. But the main difference is in this software, we have input as a DICOM images. So first, when we want to start a new project, we have to just click on the new project. So here you can see wherever your DICOM images is saved. So its extension is DCM. DICOM images extension is DCM file. It will be saved every time in your system as DCM extension. Okay, so here you can see there are so many images. So I will just click on hip DICOM and just press next. So the system will read all the file, and now as you can see on the screen, there are 106 images. Here you can see that the total number of images is 106. So we can open multiple DICOM file of the same person at the same time. And here we can also crop. If we do not want any particular section, so we can crop also. So we will just open it in the software. So now you can see at the screen that like 4 quadrants are there. So as engineering background, we all know the top view, front view, side view. So it is just like that: coronal view, axial view, and sagittal view. So if uh, I am not unable to see what the bone are there, so by just right clicking on the mouse, I can change the contrast. As you can see, the contrast is changing on the screen, right? So I can do that, and by just scrolling up and down, I can change the brightness. So I guess the bones are visible clearly. So what we are going to do, we will just segment from earlier sessions because I am also attending all the sessions from the day one. So from all the earlier sessions, everybody say that the first step is segmentation. So in segmentation, there is multiple options are there. As you can see here, new region grow, dynamic region grow. We will see split mask, edit mask, multiple slice edit. We will see all of these options one by one. Okay. So the first option is what we have done now. We have converted the DICOM images. We are now viewing the DICOM images in the system. Now we have to convert these DICOM images into 3D. So I have to just either I can do new mask or I can do threshold. Okay. So I will just do the new mask. Now here in earlier presentation of Ivan sir, he also showed us this. Here are the threshold. Here is the scroll bar. You can see uh, in left hand side in all other quadrants, the color is changing. The color changing is the mask. As I increasing the value, the bone, if I am decreasing the value, there is also muscles, soft tissues, hard tissues, and if I just click the bone sitting, so it will automatically take 226 to maximum 1698. It is the value. So similarly, if I just take the soft tissue, so it will be a minus 700 to 225. It is a predefined value. Although if I just click here and increase it, so it will change. So it is also customizable. So enamel for it is also there, for child is also there, adult is also there, compact bone, spongial bone, right? Muscle tissues. So these all other options are there: skin tissues, tooth, prosthesis. These all options are already there. So what going to do is we are going to select the normal compact bone or a normal bone, city bone. Okay. Now here is the option: fill holes and keep larges. So whenever we take the X-ray or CT scan or MRI, so what will happen? There is always a noise. There is a maybe dust is there, maybe something we have wear during the procedure. It will come into the X-ray or MRI. So for deleting all those, we will just tick these two options and just click OK. So here in the right hand side, here is mask 3D preview. And in the project management corner, you can see that one mask is created. So I will just click it and mask 3D preview. See, here you can see the 3D visualization is ready. This is not a 3D model. This is only a 3D visualization of our CT scan, right? This is not a 3D model. We have to, we can edit it, whatever the parts we want, and after we will create the 3D model. So this is just a visualization. But by just pressing Control plus Z, again I will do the same thing without these options. Okay, fill holes and keep larger. I want you to show that what the noise I'm talking about. Okay, so again I have selected that. Now by just clicking the space bar, the entire window is open. Now you can see that there is artery in front of this spinal bone, right? You can see that. So we do not want that. In earlier, what we have done, we just click on the fill holes and keep largest, right? But here we selected without, so we can edit it again in this portion. Okay. So in region group, what I have clicked region group option. So I will just connect the connectivity of 26. The connectivity is the voxels. As you can see on the screen, in the images, we talk about the pixels. So when we gave volume to those pixels, it became the voxels. So in this particular column, those 26 connectivity is for the voxels. So whatever the voxels connected to it, right? So whatever the voxels connected to each other, they will connect, and whatever this is, right? I guess this is the artery, right? So I do not want that. So I will just click here and new mask is ready. In the project management, you can see the new mask ready, and now the artery and the other things which are floating in the air are gone, right? So I will just cancel it. Now, what else we can do? Because we want either I am a doctor, physician, journal, surgeon, or I am an engineer. So in both cases, we want to find out what the problem is. And if you want to segment it, if you want to just differentiate it in these three parts, because this is the spinal bone, this is right pelvis and left pelvis, right? So if you want to differentiate it, so what I am going to do here in the toolbar, you can see that there is a split mask option. So region A, B, and because here is one pelvis, two pelvis, and spinal bone. So I will just add one more region. So you can see region A, region B, and region C. The color do not indicate anything. All right. So we can change the color. So you can see that here in the 3D option where we are visualizing the 3D model, the option is not visible, right? It is showing that I cannot choose that. Why? Because I have to choose from this images. Is this coronal view, axial view, or sagittal view? Okay. So now we want to just see that where exactly we can create is just like using the MS Paint option. Okay. So Here you can see there is a gap between these two, and there is a little bit gap between these two. So we will just like that. We will paint this. Okay. This will be our region A. So we'll select the region B, and we can change the diameter of brush also. If we want to just mark exact on the bone, so we can change the diameter and do this. Right. So this is the region B. Now region C. Before creating, here we have selected this, and after clicking the OK part, okay, we will do it again. There might be some problem because so here is a A, region B, and this region C. I can, if the parts are overlapping, so I can, and again, right. Now, as you can see on the screen, the project is divided into three parts: right pelvis, left pelvis, and the spinal bone. Okay. So as I told you, we can change the color. And so I will show you how to do that. Just go into the select any one, go into the properties, change the color, whatever the color you want. Okay. So it is not that difficult. So as we can see all of these three parts. Now again, as I told you earlier also, this is only a 3D visualization. This is not exactly a 3D model. So for converting this into a 3D model, there is one option. We can perform other operations also. Okay, before that, we can perform all other operations by using different tools, right? By these tools, and we can measure from this to this how much measure, what are the measurement, what are the dimensions are there. But as this is just for your learning purpose, so we do not need to go in that particular area, but we will just calculate part. So here, look at my cursor. Here is the calculate part. Okay, so we will calculate. There is a green and yellow mask, which we are not needing A, B, and C. Okay, and here's the quality. So if you want if you are just doing the anatomical purposes for teaching other students or just for knowing that how the bone will look in real life and you are 3D printing it for, so you can, okay, lower option, medium option, high option is there. So we will just go with the optimal option. So after calculating the part here, now, okay. Similarly, there are other options, dynamic, where we can See, the artery that was there, now it is visible by using vision. Okay, so I will just show you again how I do that, because the question is, if I am doing the hard tissues, if I am doing the bone, so it is possible to do the hard tissues, soft tissues, muscles also, right? So just by using this option, I guess you can see on the screen, right? Dynamic region group. So the values, you can change these values, okay? Whatever the values you want, you can change it. And fill cavities and multiple layers, because we want the entire artery, whatever the artery is in MRI or CT scan. So we want that. So we will just click the options fill cavities and multiple layer, and we have to find where the arteries are. Okay, so here there are seed points. So we need to select the seed point. Although this will be a very much biological site where surgeon can suggest where the arteries are, but just because I am doing this for a few years now, so I can tell you that these 2 points are the arteries, and you can also see that these two, which we are looking here, is looking different. Now because of we have selected multiple and fill cavities, this option is also selected because this artery is connected to this, right? So in this, there we created artery, right? So see, what we will do, we will just calculate part for it. We already calculated the region A, B, and C. We will calculate the artery part, right? Okay. So this hip bone with artery, right? If we want to treat this spinal, so we will just, what we will do, we will hide everything. We will hide the artery part, and we will just treat the spinal. We will just 3D print this spinal. Okay. So now what we have done, we have created the 3D model from the DICOM images. It is very simple. And also, what else we can do? So in earlier sessions, other lecturers told you that STL file for 3D printing, we need STL file. So in the file options, there is the option here, import and export. If there is already a STL file, if there is already a prosthetic which you want to check, so we can import that STL file and check the accuracy, the fit, right? And there is an export. So we can export all of this into 3D. 3D is also software of mimics, images, parts, right? We can change STL, DICOM, DXF, point cloud, and there are many other options also here. So as an extension, STL file, we can save into the STL file, and we can directly 3D print it. Okay. So what we'll do, we will just export into a 3D software. So here the software export from one software to another, because the purpose of Mimic software is to convert the DICOM images, view DICOM images into a 3D model. Okay, and if there are some segmentation or there are any requirement, so we can. The designing part is always going to be on the 3D. Okay, so as I told you that we can change the name, so we will just change the name, right? Just clicking on that. Okay, so we will export into 3D software. I will just check all options and press OK. . So we have the thematic software and mimic software. So it comes under the package of MIS, Mimics Innovation Suite, that includes mimics and okay. Here you can see the 3D model is exported. Now, as I'm assuming that you are aware of other softwares like CATIA, ANSYS. So here are the options like that: design, sketch. Okay, right. So all these the commands are already there, just like other software. So we can edit in this particular software. Okay. So this is the code. Okay. In 2 days earlier, the Sandeep Bhakre sir showed us the dentistry model. Okay. So what we will do, we will just open one dentistry part. We will take just one new project. Now, as you can see, the system is taking time for loading, right? But it is not the problem of the system or the software, because the each file we are generating is about 100 MB. Okay, so if this green mask is 100 MB, so each mask here present, like 1, 2, 3, 4, 5, 6, 6 masks are there, so it is 600 MB file, and these 4 parts again 100 to 150 MB. So it is just like 1 GB file we have created here. So that is why it will take some time sometimes. So here, as you can see, we have opened the DICOM images. Um, this is the dentistry model. Okay, this is related to dentistry. So the process is same. We are going to create a mask. The mask for it 226 to 307, which is already defined there. So we will just do the fill holes and keep larges. Why? Because we do not want that external noise in our object, right? So, and that we can change to any numbers. Okay. The already in the project management, you can see there is a named as mandible, and it is selected as 276. Okay, so what we'll do, we'll just change the value and we'll see what will happen. We'll just take a 280 or 300. Okay, and create it. Mask 3D preview. Right. So by clicking the, we can view this in the full screen. Okay. So here is the mandible and maxilla, upper jaw and lower jaw in layman language. In lower jaw, there is a defect. In upper jaw, I think it is fine. In lower jaw, there is a defect. So as I told you that in thematic software, we can edit and delete or refine the 3D parts. But in this mimics also, we can do few of those things. As through dynamic vision go, we have seen that functions. Split mask we have seen. So what we'll do, we will now use we'll edit mask will go. So just look at that edit mask. There is the option. The selected mask is there, green. I can select the mandible is also there. So, and the operation. There is 3 options. If you want to add, if I want to remove, or if the threshold is there. So if we are removing, and how I want to remove, there is a, and there are ellipse, rectangle, flat fill, live wire. Okay. So I want to delete with rectangle. So I will just click and swipe. Okay. See, you can see these are deleting now. Just I can delete whatever the part I want. Okay. So this is one option. Other options are also there. So we'll just see how the lasso will work. Okay. The lasso is just nothing but the like a rope. Okay. So we'll just create a straight line, and so this area which is inside the lasso is selected, and now it is deleted. Just like that, whatever the portion I do not want, I can delete it or edit it. Okay. So we already have a perfectly edited model, which is Mandible. Okay. So we have deleted the upper jaw because we want to work with the lower jaw. Now there are going to the thematic software. What else we can do? So we will just explore what are the other options out there. Morphology operations is there, smooth mass is there. So we will just here the other tools are there. So we will just take these 3D tools. So we will cut. We will cut with plane. Okay. So the mandible is selected, or so how I want to change. We can change the thickness, whatever we want. Keep original spec present. Okay. So what we'll do, we will just create the plane. See, the plane is created. Okay. Now, in this objects, you can see the mandible is there. Plane 1 is there. Part. This is one part. This is second part. Okay. So all these three are there. Similarly, we want to, because this is the portion where we want to fit, right? So we will just again cut with a plane. So here it is asking that which part I want to cut. So the blue part I do not want to, because we have already performed the operation on that part. So we will select the part 1. Okay. Again, same process, just creates few points for the plane, and the plane will be generated. As you can see, there is a distance between the both sides. So okay. Now, because we only want to work in this particular region. For transferring this into schematic software. Before that, I do not want this part because we want to attach new, right? So what we'll do, we'll just delete this part. So we will, whatever the part we do not want, and now this left side and right side, we will export this into the schematic software. Okay. By going into the file, export schematic. Right. And now it will ask that what I want to export. So what is visible? Part 2 of mandible, which is this one, and the part 1 of part one of mandible. So part one of mandible, this one. So we will export this from the schematic software. Here you can see the part is exported into this software. Okay. You can see there is contours are there here, and so what we'll do, we will just merge these two, so it will act as a singular part. Okay, so from object tree, I will select this by control this, and we will merge it. As you can see on the screen, there is option of merge. Okay, so we will merge it, so it will become part one of mandible. We will rename it. Okay, for our easy to learn, we will just name it mandible. Mandible. Mandible or mandible cut. Okay. Now, what we are going to do, there are many options are there for design. So we will just take anatomy reconstruction because we have contours. So we will just select one contour. Here in the operations, you can see there is options. Again, I will show you again what I done. By going into the design, I selected anatomy reconstruction. Now in the operations, here in the right side bottom, there is a contour 1, okay, which I have selected, and there is a contour 2. Okay. So these two, we can remove it also. Okay. Contour 1 and contour 2. So we want to add a contour 1, and by clicking at the contour 2, so both contours are selected. And here you can see there is a curve, there is a line is created. Okay, so this is the center line. The bone which is going to be generated is going to generate around this line. So this line is, if not looking good, it is according to me, it is not going to be create a perfect bone for that particular side. So what we can do, we can just change the length. Here you can see in the right side bottom, length of 2 is there. Okay, so we can just scroll and we can change the length. Okay. For example, we just 15, and for length 2. Again, uh, we can select any length we want. For example, I have selected 12. Okay. So now this advanced parameters are there, radial offset. These are the detailing. Okay. We can, we will use this when we are going to perform. What we are going to do here is just press apply. It will take 2 seconds. Here, you can see the bone is automatically created, right? The bone is created. But the problem is that we do not know how to connect this bone with this left and right side of the mandible. Okay, so what we will do, we have to merge all of this, first bone, second bone, and third bone. We have to merge. Okay, so what we're going to do is select this mandible cut in the object tree, right? In the object tree, mandible, by pressing Control constructed bone, and again we are going to merge. So it is created new object as mandible cut plus. If we do not want these operations anymore, so we can cancel it. Now this mandible cut, there is a surface list because we now it is merged properly. Okay, it is merged, But the problem with that is we can still these lines, right? Because it is just created the bone. Anything. It is not joined by adhesives or a screw or plate. Although it merged in the software, but it is different in actual. So what we'll do, we'll just merge with the surface, simplify surface structure, which is available here, and by shift, we will just merge all of this. So what happen when by doing this operation, what will happen? The entire product, entire object will act as a single surface. Okay. Now, but we know that here and here, in the both places, we have created the artificial bone. So what we will do by using mark with brush, we will just select. Now here again in the operations, you can see the brush diameter we can change. It is 8, whatever the brush diameter. See, the diameter is changed. So I will just select this side. Okay, but you can see the back side is not selected. So for that, there is option by just clicking on the shift. We can select two bones. Okay, now the entire portion, the entire part is selected. Similarly, we'll do for this side. Again, now the entire portion is selected. So why we are doing this? Because we do not want anything to be different. We want these three bones, left mandible, right mandible, and this artificial bone should act as a single object. Okay, single model. So we will just wrap it. So wrap, what I have done, go to the design, select the wrap operation. Here it is the mark triangles are there. So there are, you can see on the screen, there are wrap parameters. So what exactly is this wrapping is? As the name suggests, the wrap, we are wrapping the object. So if I'm saying if we are wrapping the object, that means we are we are adding a layer to it. But just because of we are adding the layer, so it should change the dimensions of the object. So for preventing that, what we have selected the reduce. Now it will go into the wrap around it, but it will also reduce. So what in short, what it is going to do, it will entire this process will help these three bones to be act as one. Okay. So it is already selected that mark triangles, and I will just press apply. So it will take few time. And as you can see on the screen, the operation is done. So what I was telling you earlier was each file we are creating, each operation we are creating. Here in the logger is there in the bottom. I have just extended it. So the operations we can see here, and each perform how much memory it is taking also. We can so estimated memory usage of these operations is around 84 MB. Each operation takes around 80, 100 or 150 MB. So the file will what GBs, right? So that operation. So we will just cancel it. Okay. Now there is a mandible cutler which we have created, which were working, and now another part is mandible cut plus wrap. Both are there. So we will just hide the old one. We do not. Okay. So this is the new mandible wrap. Okay. There are no lining here. So that means we have joined these three bones into. The thing is, the plate is the we want to create a plate. We want to produce a plate. So for that purpose, we can just create what I have done, sketch, create curve, and in the right side bottom, you can see there are intersections, closed curve, or other general options, what kind of curve I want to attach curve, contour curve, smooth curve, right? If you, we can also use that. So we use here smooth curve, and here the attached options are there. Attract curve, attach curve. So these are all the options. I'm going to just create a curve from this side. Right now, I am creating this randomly because there are instructions from the doctors that where this curve plate we want. So I am just creating this plate randomly. Okay. Now I will just apply it. As you can see, the curve is created. Now, when we create custom plate, now when I create custom plate, the the width is there, thickness is there, chamfer distance, inner and outer. So by just selecting on this curve, okay, as you can see on the screen, the green color portions are the what are those? Those are screw holes. Those are okay. So this is how we are going to create a plate. By just we can change. Okay, I will show you screw hole parameters. So outer diameter we will change. It is right now it is 4. We will do 5. Or inner diameter it should be lesser than that. So let just take 3. Okay. So after applying, it will take few seconds. As you can see on the screen, the plate is created. It is not the ideal plate we want because the one plate is gone here. Whatever the requirement will be, we can create the plate according to that. And here you can see we have created the screw diameter. So it is also there. Right. So this is how we have created the plate. So what we have see today, we have seen how to generate icon images to visualize 3D, 3D part to 3D model. Now for the hip, right, and now for the dentistry, we have seen as earlier Sandeep Dhake sir showed us this kind of plate in his presentation. So we just created just like that. So I think the next session is from 3:30 p.m. Okay. So I will now 10 minutes is left. So I will just open the floor for the discussion. If anybody have any kind of questions, you can ask me, right? Okay. If you have any questions or any confusion regarding this, so you can ask me.
Thank you so much, Venkatesh Naidu, for such an insightful session. We are now open our floor for the questions and discussion. All the participants, please feel free to share your queries into the chat box.
Yes, there are software. So the thing is, Muthu Kumar sir asked any other open source software will do the mimic purpose. Definitely, there are many open source software which are present. But the thing is, for converting the DICOM images for just DICOM images to visualization, there is one software. So, and likewise, there is a software called 3D model. For editing, there is another software. So, this entire thing in single software, which is very difficult to find, are options if we want to do our work for in Mimics and thematic software, you just have all of those options and modules in the same software. Okay. I hope I gave you correct answer. Manalkar sir has asked that, can you enlist or biomedical softwares? Sir, there are many biomedical softwares. Sir, Dentistry, there is Blue Sky Plan, Dentsply Sirona, and just like that, these are the software for other particular body parts. There are different softwares, but what mimic from head to soft tissues, hard tissues, muscles, and bone. We all of these. So mimics. Any other? Is there any other question? Which one should be slicer? Which one is more user friendly? See, as you can see today, the user friendly mimics is very user, and you can do the PhD work in mimic software. But the main problem is about the availability. If you want to use mimic software, you Raju sir and Dr. AICTE sir also, they will cooperate with you, and you can, as Raju sir also mentioned before, that you can use the mimic software Raisoni College for free. But yes, you can contact with them. 3D Slicer is a good software, but if you want to use all the modules, all the operations, you should go for the mimics, and you can work in the mimics. Another question from Chiranjeevi Meka sir. Thank you so much, sir. Which one should we work in? Okay, I have answered this. So one question, while deleting the upper jaw, how we will make sure the required part is not. The question is correct. So again, go to that particular place. Okay. So here on the screen, you can see on the screen, you can see that the defect is in only in lower jaw. So we do not want anything. If we just edit the tooth also from the lower jaw, it will not create any nuisance. It will not create any problem for the design. We just lower jaw bone, right? So we do not need to go for detailing for this kind of work. But again, yes, if we want exact replica, so we have to just put more some time, and we will get the right model. Okay. So I think I have question. So now over to you, Nilesh sir. Thank you so much, and I would like to thank for giving me opportunity for explaining this paper to all, and also I would like to thank AICTE sir for maintaining this, completing this session from first day one, and sir for hosting the event so gracefully. Over to you, Nilesh sir. Thank you so much.
Thank you, Venkatesh. Yeah.
Thank you, Venkatesh sir. On the behalf of all the participant and organizing committee, I extend our Heartfelt gratitude to Dr. Venkatesh Naidu for sharing his valuable knowledge and practical insight. Your presentation has truly broadened our understanding of mimic software and 3D matrix. Thank you so much, sir.